Today we are going to learn about Agarose Gel Electrophoresis. Agarose Gel Electrophoresis is often known as AGE. It does the separation of DNA molecules when an electric field is applied on them. So, the DNA molecules, when an electric current is applied on them, it separates and fragments of DNA are obtained. This separation is based on the net electric charge, size, shape, as well as the applied electric current. So based on the net charge, size, shape, and applied electric current, the separation of DNA molecules occurs. A general equation is given, that is V is equal to E into Q divided by F, where V is the velocity of migration, E is electric field, Q is net electric charge, F is the frictional coefficient. So Agarose Gel Electrophoresis is a technique that separates a DNA molecule into fragments. It does the separation of charged molecules. So we know the DNA is a charged molecule. It has a negative charge, and more about the negative charge we will discuss in the next slide. The next topic that we are going to cover is working of Agarose Gel Electrophoresis. We know that the DNA has a distinct chemical nature. It is made up of nucleobases, deoxyribose sugar, as well as a phosphate group. And it is this phosphate group that gives DNA a negative charge. The negative charge is due to the phosphate group present in the DNA. And this is the structure of DNA. It has nucleobases, deoxyribose sugar, as well as a phosphate group. It is this phosphate group that gives DNA a negative charge. The next topic that we are going to cover is gel matrix. The gel matrix used in Agarose Gel Electrophoresis is a natural polysaccharide, that is agarose. From the name itself, we know it is agarose. This agarose is derived from the seaweed. So, the gel matrix used in Agarose Gel Electrophoresis is agarose. The basic principle of Agarose Gel Electrophoresis is that smaller molecules migrate faster and larger molecules migrate slowly. This is the basic principle, that smaller molecules migrate fast and larger molecules migrate slow. And based on this difference that the migration occurs. This diagram shows that the tray is captured with a gel matrix. The gel matrix used in Agarose Gel Electrophoresis is agarose. This diagram shows that the seaweeds from which agarose powder is being obtained. The next topic that we are going to cover is running of the gel. A typical age is captured on a horizontal slab. It uses plastic combs for creating wells. The DNA is mixed with the loading die so that we can track its position when it's run. It also has a DNA ladder which has no length of DNA. So this is used for comparison of the unknown length of DNA from the sample. This diagram shows plastic comb as well as a DNA ladder. The plastic comb are used for creating wells, and DNA ladder is used for the comparison work. It compares the unknown DNA with the known DNA present in the DNA ladder. The gel is then placed on a container. The container is called gel tank or gel box. This is filled with pH controller buffer solution. It is usually of fis acetate EDTA or fis borate EDTA. And because of the negative charge of the DNA, that is due to the phosphate group, it migrates towards the positively charged electrode. That is, from the cathode, it moves towards the anode. This diagram shows that the overall migration of DNA molecules. The first figure shows that the wells are created using plastic combs. The second figure shows that the DNA is loaded to the wells. The 3, 4 and 5th diagram shows that the migration slowly progresses. The 6th diagram shows that the migration is almost completed and the separation of fragments occurred. The last and the final step of Agarose Gel Electrophoresis is the visualization of the DNA. Immediately after the DNA is being migrated, it has to be visualized. Since the DNA is not visible to the naked eye, there is a need to be visualized. We either use a colored stain, that is methylene blue, or a fluorescent stain, that is ethidium bromide. Ethidium bromide is frequently used for staining of agarose gel electrophoresis. By visualization of the DNA, we determine the length as well as the abundance of a molecule in a sample. When a DNA is bound to the fluorescent stain, it fluoresces under the UV light and gives a reddish-orange color. This diagram explains that the migration is completed and the DNA is bound with a fluorescent stain to give the fluorescence under the UV light. It gives a reddish-orange color so that we can visualize the DNA. The equipment used for agarose gel electrophoresis is a gel tank or a gel box, power supply, and a gel documentation. So there are 3 equipments used in agarose gel electrophoresis, which are a gel tank or a gel box, a power supply, and a gel documentation. This diagram shows the overall setup of agarose gel electrophoresis. It has a power supply, a cathode and anode. The DNA is being loaded at the cathode and allowed to migrate towards the anode. The matrix is made up of agarose. The wells are created at one end using plastic combs. The sample is loaded in these wells. The gel is then dipped in an electrophoretic buffer. Once the power supply is on, the migration occurs and DNA moves from cathode to anode. Different fragments of the DNA are obtained. Summarizing the reagents that are used in agarose gel electrophoresis. First is agarose powder. Agarose powder is used so that we can make the gel matrix. Buffer. Buffer is used to provide the ions that carry current and maintain the pH level. Loading die. Loading die is used to track the position when the DNA is run. DNA ladder. DNA ladder is used for the comparison of unknown DNA lengths with the known DNA lengths present in the DNA ladder. Visualizing stain. It is used for the visualization of the DNA. Hope that you have understood the concept of agarose gel electrophoresis. Please do like, share, comment, and subscribe for more future videos.